Today we're going to be solving word problems through substitution, and these problems have to do with age. So let's look at a couple of rules. Younger means less. Older means more. And that's very important because when it comes to word problems, you're going to see the word older and younger quite a bit. And older means more and younger means less, and that makes sense. If you're younger, you have less years. If you're older, you have more years. And so let's look at our first problem. Adam is 20 years younger than Brian. In 2 years, Brian will be twice as old as Adam. How old are they now? Now, before we solve for this problem, a couple of things. As you've noticed and as I've told you, I solve problems different from Mr. Wallace. I solve problems different from most mathematicians. And one of the things that I like to do is to write things out the way they're spoken in the problem and then solve through substitution. I also like to stay away from X and Y. And in this problem we have Adam and Brian, so we're going to have A and B. Now Adam is, that's the equal sign again, 20 years younger. Now remember I said younger means less. That means we're going to subtract. And of course that less, that negative sign goes in front of the number, not behind it. So Adam is 20 years younger than Brian, and we are going to use a B for Brian. So A for Adam, B for Brian. And that's just the way that this problem is written. Adam is 20 years younger than Brian. And in 2 years, Brian will be. Now remember we said that will be is the same as is. So there we go with the equal sign. Is the equal sign. Will be is the same as is. In 2 years, well, Brian, whatever age he is now, in 2 years he's going to be how old? B plus 2. Twice as old as Adam. Now twice is the same thing as double, is the same thing as 2 times. So it's 2 times whatever we're going to put in here for Adam. Now how old is Adam going to be in 2 years? Well, in 2 years Adam is going to be A plus 2. Remember, it didn't say he'll be twice as old as Adam is then. It says twice as old as Adam. So we assume that means now. And we multiplied out our parentheses and we end up with 2A plus 4. And now we have 2 formulas that are written pretty much the same way they were spoken. I know that we kind of multiplied that out. So we are going to substitute this into this or this into this. Okay. In the lower formula, do we know what B equals? No, we really don't, because we'd have to get rid of that too. Do we know what A equals? No, because we'd have to get rid of that 2 and that 4. Here we know what A equals. A equals B minus 20. As you can see, it might be easier if we figured out what B equals. B equals A plus 20. And you can do that work if you like. But we're going to take the formulas just the way they sit. And we're going to use A. And A is going to equal B minus 20. And we're going to fit it into this A here. So this is going to be 2 times parentheses. And this parentheses is going to substitute for A. It was 2 times A. Now it's 2 times parentheses. Now what does A equal? I've said it 3 or 4 times so far. A equals B minus 20. And so that's what we're going to put in the parentheses. We're going to put B minus 20. And the reason why I'm saying it so often is because when you first start doing substitution, it sounds like I'm pulling numbers out of everywhere possible, but I'm not. we just have two problems. We have two formulas. I'm substituting one formula into the other. And it doesn't matter which formula you substitute into the other, as long as we get it down to a variable equals something. And this is the only variable we have that says this variable equals something. So what we had here is A. I'm going to put B minus 20 in there. There we go, just like that. And now we have B plus 2 equals 2 times this parentheses plus 4. So multiply 2 times everything in the parentheses. And that converts to 2B minus 40. And as you can see in this bottom formula here, we have one variable. We have one variable, now we can solve for it. That's right, we're going to add like terms starting with the units. We had negative 40 and positive 4, and that leaves us with negative 36. We don't have any more like terms, so let's start moving some stuff around. How about if we move the units over to this side by adding positive 36 to both sides of the equation? That will eliminate 36. That'll eliminate all the units on this side. And if we bring everything down, we will have all the units on the left-hand side. Now we need to move all the b's to the other side. So let's move this b by subtracting b from both sides. So that will remove b from this side. And 2b minus 1b, remember b equals 1b. 2b minus 1b equals 1b. And don't forget to bring the 38 down. And b equals 38, or 38 equals b. So Brian is 38 years old now. And we need to find out how old Adam is. How are we going to do that? Well, we're going to insert the value for b back into the top equation. That's right, since b equals 38, we can put that into the top equation. And a equals 38 minus 20, which is 18. A is 18. So right now, Adam is 18 years old and Brian is 38 years old, and that is the answer to our question. Now let's do a couple more of these and you'll see that after a while it becomes pretty smooth. Carmen is 12 years older than David. 5 years ago, the sum of their ages was 28. How old are they now? So our first sentence said Carmen is 12 years older. Older means plus. 12 years older than David. And that's pretty simple. That gives us our first formula. But our next formula says 5 years ago. Well, in our first problem, it said in 2 years. That's the future. In 2 years, will be is the verb that they used. That's the future. In the future, we add years. In the past, we subtract years. So there you go, just write like this. Remember, we always put the new ages in parentheses because we're going to be adding or subtracting numbers. Or let me put it this way, that could be in the first sentence, and whatever the age is where you're adding or subtracting numbers, put that in parentheses. So Carmen 5 years ago was C minus 5. Whatever this age is right now, 5 years ago it was C minus 5. David, his age 5 years ago, right now his age is D. 5 years ago it was D minus 5. And it said the sum of their ages was is the same word as is, so it means equals, was 28. Okay, so let's bring everything out of parentheses, and since there's a plus in front of all the parentheses, that won't change anything. And let's add like terms, like we saw in the first problem we have. In the first formula in both problems, There's nothing to add or change. But down here, we have 2 units that we can add. -5 plus -5. -5 plus -5 is -10, and we're going to move this -10 to the other side of the equation. And we'll bring that down. And c plus d equals 38. Now, the only variable that we have alone, this isn't alone, this isn't alone, this is not alone, this is. We do know what c equals. C equals d plus 12. So let's replace this c with this c. This c equals d plus 12. So why don't we put d plus 12 right here? Yeah, that looks good. And let's add our 2 d's. Let's get all of our units on one side. And so let's move this 12 over to here. Let's bring all that down. And 2d equals 26. Let's divide both sides by 2. That'll isolate our d. D equals 26 over 2, or 13. David is 13 years old, and let's insert this d back up into the first formula. Oh wow! Carmen is 13 plus 12, which is 25. Carmen is 25 years old, David is 13 years old, and that is the answer to this question. Now, remember, I don't do a lot of checking of my work. You can take my work and plug it back into the formulas to make sure that you have the correct answers, especially if you do a lot of long, hard work on a problem. It only takes like a minute to plug those numbers back in. And if you do it for problems like this, plug it into both formulas. But let's do another age problem. The sum of the ages of Nicole and Kristen is 32. In 2 years, Nicole will be 3 times as old as Kristen. How old are they now? Okay, so the sum of the ages of Nicole and Kristen is 32. Sum means plus, so we're going to add their 2 ages together, and it is 32. In 2 years, Nicole will be. Nicole in 2 years will be is 3 times as old, so 3 times parentheses, Kristen. And that's Kristen in 2 years, not Kristen now. In 2 years, both of them will be 2 years older. So let's take this out of parentheses by multiplying the 3 times everything in the parentheses, and let's get rid of these parentheses too. Let's get all of our units on one side, and since we have 1n here and 3k here, it's going to be nice to have n alone. So let's get rid of that too, and bring everything down. And n equals 3k plus 4, and that's interesting, because if we look at both of our formulas, it's the second formula that has an isolated variable. The variable here is not isolated. You could do n equals 32 minus k if you get the k over here, if you can do that in your head. We don't want to do stuff in our head. Or we could say k equals 32 minus n if you get the n over here. Again, we don't want to be doing that in our head. 3, we don't want to be dividing k by 3, or we don't want to be dividing anything by 3. But we have an isolated variable here. We know what n equals. N equals 3k plus 4. And we can insert it into our first formula. So this n, 3k plus 4, is going to become 3k plus 4. And as you can see, we have one variable in the formula. Down here we have 2 variables. We had 2 variables up here, but by substitution, we got rid of the n. So now we have no units that we can add. We have 2k's that we can add. We have 3k plus k is What's 3k plus 1k? It's 4k. So now 4k plus 4 equals 32. Let's bring this 4 over. And we'll get rid of all that work in the middle so that we can see what we're doing now. So let's bring all that down. Divide both sides by 4. And I'm writing really small because we're running into the other formula. 4 over 4 is 1. 1 times k isolates our k, and k equals 28 over 4, or 7. Okay, well, Kristen is 7. And we can substitute that 7 into this k here. That's one of the things we can do. 3 times 7 is 21. 21 plus 4 is 25. Nicole is 25 years old. Kristen is 7 years old. And we could have taken that 7 and substituted it into the first formula. Let's try that. Our first formula was n plus k equals 32. Let's substitute in the 7 here. And now we have n plus 7 equals 32. Let's subtract 7 from both sides. And if you do that, that's going to isolate our n, and 32 minus 7 is 25. So Nicole equals 25, Nicole equals 25. And the reason why I did that, you don't have to, but the reason why I did that is to show you that once you solve for one variable, it doesn't matter which formula you substitute that into. You can substitute it into the first formula or the second formula. I just like to substitute it into the formula that's the easiest. So we've had 3 problems that are teaching us something new, and the fourth one is going to teach us something even newer. Louise, he wrote Louis, but I think he means Louise. Louise is 26 years old. Her daughter is 4 years old. In how many years will Louise be double her daughter's age? Now that's interesting. In the previous problems, they asked what the ages were. In this problem, they tell us what the ages are. In the previous problems, they told us how far into the future or how far into the past we needed to go. In this problem, we're going into the future, but they don't tell us how far into the future. So the future is going to be our variable. So you can use f for future. I like to use time. And here we have our first 2 formulas. Louise is 26. Daughter is 4 years old. And let's build the other formula. So in the future, Louise, now we know that L equals 26, but I'm putting L there so it's real clear what I'm doing. We'll substitute 26 in later. Louise plus sometime into the future will be double, that's 2 times parentheses, her daughter's age. That's her daughter's age in the future. So her daughter is going to be D plus T in the future. That's how old she'll be. Now we know how old Louise is now. She's 26 years old, so in the future she'll be 26 plus T. And her daughter, in the future, her daughter's going to be 4 plus T. Okay, so let's bring this out of the parentheses, and since there's a positive in front of it, we're not going to change anything. And since we have a 2 in front of this parentheses, we need to distribute that 2 to both of these items. 2 times 4 is 8, and 2 times t is 2t. So let's bring this t over here, since it's the smaller t. That's right, we're going to subtract t from both sides. That's going to remove that t. T minus t is 0. 2t minus t is 1t, and let's bring everything else down. Let's isolate our t by moving the 8. Let's bring all that down. And t equals 18. So time equals 18. That is, 18 years into the future, Louise is going to be twice the age of her daughter. So that's the answer to the question. They asked you, how far into the future is this going to happen? It's 18 years. And that's the solution to this problem. And if you do your homework below, you'll get a lot better at this.